Rough terrain and high mountains result in minimums sector altitudes of more than 15,000 feet. A satellite navigation system with global coverage is termed a Global Navigation Satellite System, GNSS. As per today, only the United States Navstar Global Positioning System, GPS, and the Russian GLONASS are global operational GNSSs. Currently, the only GNSS system fully operational and for which approval material is available is GPS. Currently, equivalent approval material for GLONASS is not under development, but it will need to be available prior to approval of any GLONASS-equipped aircraft for MNPS operations. State approval of unrestricted operation in the MNPS airspace may presently be granted to an aircraft equipped with at least 2 fully serviceable long-range navigation systems. A long-range navigation system may be one of the following: 1 Inertial Navigation System, INS, 1 Global Navigation Satellite System, GNSS, or 1 navigation system using the inputs from one or more Inertial Reference System, IRS, or any other sensor system complying with the MNPS requirement. Required Navigation Performance Capability, RNPC airspace, is defined as a controlled airspace within the Canadian domestic airspace. RNPC airspace accommodates area navigation (RNAV) operations and is contained within the Southern Domestic Airspace (SDA) and Northern Control Area (NCA). To operate an aircraft in RNPC, aircraft and crew have to be certified by the State of Registry or State Operator. Aircraft and flight crews are considered to be certified for RNPC airspace if they are certified to operate in NAT MNPS or CMNPS airspace. As a result of passenger demand, time zone differences and airport noise restrictions, much of the North Atlantic NAT air traffic contributes to 2 major alternating flows: a westbound flow departing Europe in the morning and an eastbound flow departing North America in the evening. The effect of these flows is to concentrate most of the traffic unidirectional, with peak westbound traffic crossing the 30 west longitude between 11:30 UTC and 1900 UTC, and peak eastbound traffic crossing the 30 west longitude between 01 UTC and 08 UTC. Position Skylift 100 on 8831. Resno at 1235. Flight level 330, estimating 56 north, 20 west at 1310, and 56 north, 30 west next. A standard position report normally contains the following elements: call sign, frequency being used, current position with time, flight level, next position with the estimated time and the subsequent position. For aircraft cleared by Shanwick OAC on random routings in the NAT region, the present procedure of reading the full track coordinates as part of the oceanic clearance, and requesting from the pilot a full readback of the coordinates is expected to continue. Gander and Reykjavik OACs may, however, issue clearances for random routings which specify via flight plan route. Nevertheless, in all circumstances regarding random route clearances, pilots are required to read back the full track coordinates of the flight plan route from the oceanic entry point to the exit point. The purpose of a flight plan check is to ensure complete compatibility between the data in the flight plan and the calculated output from the navigation systems. The letter X shall be inserted in item 10A of the flight plan. If RLAT-SM tracks are intended to be used, the pilot must ensure that the aircraft data link capability J5, J7, D1 and the RNP4 capability L1 have been filed. The manual entry of waypoint data into the navigation systems must be a coordinated operation by 2 persons, working in sequence and independently. One should key in and insert the data, and subsequently the other should recall it and confirm it against source information. It is not sufficient for one crew member just to observe or assist another crew member inserting the data. The strategic lateral offset procedures, see Chapter 8, are now standard operating procedures throughout the NAT region. Thus, when flying within NAT MNPS airspace, if the aircraft encounters wake turbulence and the pilot considers it necessary to offset from the current track, then the pilot may only elect to fly another of the three options allowable in SLOP, i.e. cleared track centerline, or 1 nautical miles or 2 nautical miles right of centerline. It is no longer possible to offset left of the track centerline to avoid wake turbulence. If neither of the remaining SLOP offset tracks are upwind of the other aircraft, which is causing the wake turbulence, then the pilot should coordinate with the other aircraft via the inter-pilot frequency 123.45 MHz, and perhaps request that the other aircraft adopt an alternative SLOP allowable downwind offset. Pilots must appreciate that ATC can only provide a revised clearance which will continue to assure that minimum standard separations are maintained from all other traffic, including any on adjacent tracks. When this is not possible, ATC will advise the pilot unable and will request the pilot's intentions. Only in the event that a revised ATC clearance has not been obtained, the following contingency deviation procedures should be adopted in their entirety. If possible, deviate away from the organized track or route system. Establish communications with and alert nearby aircraft, broadcasting at suitable intervals on frequency 121.5 MHz, or as a backup on the VHF interpilot air-to-air frequency 123.45 MHz. Watch for conflicting traffic, both visually and by reference to ACAS-TCAS, and turn on all aircraft exterior lights.